Hi everyone, I'm Cheryl. In this problem, we're asked to find dw dt in two different ways. First, we're going to find dw dt by using the chain rule, and then we're going to convert our function to a function of t before we differentiate. All right, so the function we're given is w equals x squared plus y squared plus z squared, where x is the cosine of t, y is the sine of t, and z is e to the t. So let's begin with the chain rule. So if I want to find dw dt, I'm going to take the partial of w with respect to x and multiply it by dx dt. I'm then going to add this to the partial of w with respect to y times dy dt. And then add that to the partial of w with respect to z and multiply it by dz dt. Okay, so the partial of w with respect to x. I'll be treating y and z as if they're constants, so that derivative is just 2x. dx dt, because I know that x is the cosine of t, dx dt is going to be minus the sine of t. The partial of w with respect to y. When I come up here to w, I'll be treating x and z as if they're constants, so that derivative is going to be 2y. dy dt, because I know y is equal to the sine of t, dy dt then is the cosine of t. Once again, moving back to my w, the partial of w with respect to z, I'll treat x and y as if they're constants, and so that partial is 2z. And then dz dt is just going to be e to the t, because z equals e to the t, and it's its own derivative. All right, so let's simplify this a bit. I'm going to have a negative 2 times x. Now I know x is the cosine of t, and I've got my sine t. For the next term, I'm going to have 2y. Y I know is the sine of t. So I've got sine t and then cosine t. And I'll have 2, z is e to the t. So I'll have e to the t times e to the t, which is e to the 2t. Now notice that even though cosine t and sine t are written in different order, multiplication is commutative. So those two terms add together to be 0, and dw dt is 2e to the 2t. Now that's finding dw dt using the chain rule. The next thing we're going to do is we're going to convert w, which is x squared plus y squared plus z squared, into a function with only t's. So I know that x is cosine t, so x squared will be cosine squared t. I know that y is sine t, so y squared will be sine squared t. And I know that z is e to the t, so z squared will be e to the 2t power. Now, one thing I notice here is that I have cosine squared plus sine squared. I can use my identity to say that w then equals 1 plus e to the 2t. And I have w expressed as a function in terms of t only. So dw dt then is simply its derivative. The derivative of 1 is 0, and the derivative of e to the 2t is e to the 2t times 2, or 2e to the 2t. And notice that my two answers are exactly the same. I hope that was helpful. Thanks.